Hi, today's video is to get you familiar with graphing quadratic functions in intercept form. So last week we talked about standard form, which is this ax squared plus bx plus c, and that was useful for some things, but we're going to talk about intercept form today. And intercept form looks like this down here. Y equals a times x minus p times x minus q. And those values of p and q, are pretty important. They tell us things like the x-intercepts. And if you remember what x-intercepts are, they allow us to find those values on the x-axis, we have one x-intercept here and one there. Doesn't matter which order you have them in because it's going to give you both no matter what. The axis of symmetry can be found from this form as well. It is p plus q over 2. So that's something you would definitely want in your notes. A still has the same control as it did before. So it's going to open up if A is positive and open down if A is negative. Those things, A is never going to change what it does to the parabola. Let's graph a couple quick and then let you go to your homework. So when we see these in intercept form, we definitely want to identify the values of A, P, and Q. So in this example, we have A is -1. We have P is -1 because we have to think of this as x minus a value. So that's x minus -1. And we have Q is -5. We want to find our special things like the axis of symmetry. That is x equals -1 plus 5. Sorry, I wrote this as -5. It is 5. Well, -1 plus 5 over 2, which gives us 4 over 2, so 2. Vertical line x equals 2 is our axis of symmetry. To figure out what y is, we just plug in 2. So I'd have 2 plus 1, 2 minus 5, and we would get -1 times 3 times -3, so we'd get a +9. That helps me find that vertex point. That is a super important one to plot. So let's go over to our graph paper and plot all of the things we know and see if we can figure out what the parabola looks like. So we're going to have an axis of symmetry at x equals 2. Right there. Remember, those are dashed lines. And we have a vertex of 2, 9. Right up there. Our intercepts of -1 and +5. Right there. And that gives us a decent idea of where our parabola goes. But remember, we can also do our 1-3-5 trick from last week and go from our vertex, right 1, down 1 because of the -a, and then right 1, down 3, and get some more points. And if we reflect those across, we get things that do this. And then I can draw a really nice parabola in there. Nice smooth curves, and there you go. Let's look at this one. A little bit different. We have an A value of 1, a P value of 3, and a Q value of -2, because remember that x plus 2 is really minus a negative. That tells me my parabola opens upward because A is positive. It tells me my axis of symmetry is going to be 3 plus the -2 over 2, which is x equals 1/2. And then to find the vertex, you plug in 1/2. So you get 1/2 minus 3 and 1/2 plus 2. And if you plug that into a calculator, this should be negative 6.25. So we can plot everything we know again. Our x-intercepts of 3 and negative 2. Our, oops, I forgot the axis of symmetry at 1/2. We're going to have to squish it in here because I didn't give myself nice graph paper. Okay, and then our vertex right there on that axis of symmetry at negative 6.25. We'll have to estimate where that goes, about there. And we can kind of see our shape. It opens upward, so it looks something like this. Oops, I missed my dot. Something like that. Do your best to draw nice curvy parabolas. We could have absolutely, and probably should have, done the 1, 3, 5 rule. Pretty close there. Pretty close there, so it's all right. Okay, so when they're given to us in intercept form, they're not super terrible. They're pretty easy to find the things. But what if they're not given to us in intercept form and they're given in standard form? Then you have this hint here that factoring is absolutely your friend. So we're going to get to factor a couple more times. So first thing, we take out GCFs. So greatest common factor there is 2. And then we notice that x squared minus 4, this guy right there, is difference of 2 squares. So that factors as x plus 2 and x minus 2. You may need to review some factoring rules if you have forgotten them. Okay, now it's in intercept form and we can identify our a value is 2. So parabola opens up. We have a p value of 2, negative 2, and a q value of 2. Again, those could be in any order, it doesn't really matter. We have our axis of symmetry, x equals negative 2 plus 2p plus q over 2, which is going to end up to be 0, because 0 divided by 2. And then vertex, you can plug that x value into either spot, the factored form, or your original standard form. Standard form looks a little bit faster. So y equals 2 times 0, goodness, squared minus 8. So that's going to be a vertex of 0, negative 8. Okay, let's again plot what we know. Our x-axis is, or our axis of symmetry is the y-axis. So do your best to make that axis of symmetry visible, even though it's on that bold axis there. Okay, it's important we see that. And then I have a positive 2 intercept and a negative 2 x-intercept. And a vertex of 0, negative 8. 1, 2, 3, 4, 8. I think that was 8. And again, if you want some more points, you can do your trick. But this time, because a is 2, we go right 1 and up 2 to get the next point. We go right 1 and not up 3, but up 6, which gives us our intercept point. So if I reflect this other one I found, I would have my 5 nice points for a parabola. This one, because of the 2, did get narrower, so it's harder to get that not pointy parabola in there. So sorry about this strange mistake there. Fix it as best I can. All right, something like that, but do your best to hit all your points and make this a nice, smooth, curvy parabola. Okay. I think we have one more to go through, and then I'll let you try on your own in your homework. Again, factoring, here we are in standard form, so we want to factor and make sure that we can find our a, p, and q values. So first, let's do some fun factoring. I noticed that all of these have a negative Definitely want to factor out a -1 as a greatest common factor anytime this a value is negative. Factor that out as a GCF. That would make x squared plus 9x plus 18 there once you do that. Then you get to factor that quadratic. And we're looking for numbers that multiply to 18 and add to 9. So x plus 6, x plus 3, really good ideas for that. Now, as in the last one, we can identify a, -1, which tells us this parabola opens down like a frown. And p is going to be a -6, because plus 6 means minus negative, and q a -3. So our parabola is definitely over to the left of the y-axis with those intercepts that way. And the last thing, well, not the last thing, the axis we want, -6 plus -3 over 2, gives us an axis of symmetry at -4.5. A little calculator work on the side there. And then to find the vertex, because that's super important, we know, we're going to plug in -4.5. Again, factored form, if you want. Either one will get you the correct vertex. Sorry about the strange zooming there. So -4.5 plus 6 and -4.5 plus 3 gives us a y value of 2.25. Okay, let's plot it all and see what we get. Axis of symmetry at -4.5. 1.5. Again, estimate to the best of your ability where that goes. The vertex is on that line up 2.25. So put it best you can. And then I need a -3, -6. Right there. So we have an idea that our parabola does this. We knew it was going to open down, and it definitely did. Hopefully this helps you tackle your homework. If you have any questions, please do let me know.